Kubernetes, and we'll also just highlight some of the concepts behind these and how we can use it practically. Have a bit of practicals. So, okay, serverless computing. What do we mean when we refer to the term serverless computing? Is a way of hosting your applications in the cloud. So when we talk about serverless computing, we're actually referring to a way of hosting your applications in the cloud. And serverless computing is a cloud hosted execution environment that allows customers to run the applications in the cloud without dealing with sort of removing the infrastructure. When we talk about infrastructure, we're talking about the cost of maintenance like data center, on-premises servers. You know, to manage a data center alone, it's work. I personally, my current office now, we manage a data center too safe, and I know how much work we put in. Sometimes they'll tell you the temperature of the data center has to be a certain degree. You have to look at the spacing, the connections, cabling, too many other factors are involved. So when we talk about serverless computing, what we're simply saying is that we're having a cloud-hosted execution environment without dealing with all the on-premises infrastructure. And maybe you have to get a building, ensure there's power, there's NEPA, there's all those things. In our country like Nigeria, for example, might be difficult. So having a serverless scenario is very key. So I'll move on to when we talk about serverless computing, like I described. I'll move on to some of the key areas of serverless computing in Azure. We're dealing with Microsoft Azure. So one of the key areas we talk about Azure functions. And when we talk about Azure functions, we talk about logic apps, we talk about event grid. Under Azure functions, I'd like to start with when we talk about Azure functions, we can simply describe these Azure functions as allowing customers to build applications using packages or that deploy themselves across multiple services to communicate with your application. So what I mean is, when we deploy an application using Azure functions, so what we're doing is we are creating a serverless coding platform that functions as a service. That's what we call FaaS, function as a service. So we're allowing customers to build applications on Azure using package codes. So if you let's just go back a bit. You know, I don't know if most of you here have done some coding, but some knowledge of coding will be important here, where you have to deal with frameworks, and your framework has libraries, and usually those libraries carry the functionality, special functionalities. So in this case, we're talking about 3 Azure functions. What this does is that it provides you with services that enables you to connect with external services. It provides you with services that enables you to connect with external services. So what it does is you're able to build applications with code, but you're able to deploy those applications across multiple servers. So for example, I build an application here. I don't need to start looking at how it would connect to the servers. I'm not bothered about that. I'm not bothered about how it connects to multiple servers. All I need to do is to use an Azure function that would enable me to connect to external services. So here, like I said, Azure functions allows customers to build applications using code, the packages across multiple servers, and allows external services to communicate with your application. It enables scaling up and down. When we mean scaling up and down, means that you can expand horizontally, you can expand vertically. I will highlight some of the key features of the Azure functions. One of the things that characteristics it has that it has been designed for nano service architecture and event-based applications, meaning that it can deal with messages from your events. It can keep a record of events from your event-based applications. It can scale up and down very quickly. It is highly scalable, meaning that you can have over 200 servers connected using Azure functions. It supports popular languages. So you don't have to go and start thinking of, oh, for example, a programming language like Python, Java, .NET, it supports them. When we say it supports them, what we mean is that it's able to incorporate your Java, Python into the Azure functions, and you're able to create applications. So you're not thinking of how best Python can be translated. But once you merge it with Azure functions, you can create applications, even though you had done your initial coding with Python or with PowerShell or with .NET or with Java. You can easily incorporate it so that it supports these languages and frameworks. Sorry, excuse. I'll move on to the other one, logic apps. Logic apps. What does this enable us to do? It enables us to build workflows. You can do loops. I'll be summarizing some of these things because also aside time, because in this class we're dealing mostly with just the basic, or rather the curriculum is the basic for this class. So when we talk about the Azure logic apps, we're talking about how to build workflows. What do we mean by workflows? Processes. So for example, you say, okay, I want I don't know how many of you are familiar with the normal Nigerian post office. So you say, okay, you have a mail or you have a letter. Back in the day when we used to deal with letters in the Nigerian postal service. So, imagine a post office where you have different departments. There's a collection department. There are people who are responsible for address. They separate the address system. So, okay, somebody sending a letter from Lagos, somebody sending a letter from Sokoto, somebody sending a letter from London. They sort. They have the sorting team. Then they have the ones that send dispatch, that take out the letters. Then they probably have logistics team that arrange logistics for transportation. When we talk about the logic apps, when we talk about building workflows, what we're saying is that we're building a system that works. We're building processes from point A to point B to point C. How do you go? We're building, so that's what it is, building workflows. You can also do loops under logic apps. Loops in the sense that you can create a function that says, oh, if so person is not at home, or if let me use a normal program that we usually use. If the data is correct, click yes. If the data, for example, you put in your name on a form, if the name is not correct and they've checked the database, the name is not correct, put the data as yes. If the spelling is not correct, put the data as no. Put the data as no. So you created a loop. And usually loops are created as a form of sequence. when you are programming. Like when you are creating a loop in programming language, let me just try to make it. Talking about logic apps. Okay, we're talking about logic apps. So what do we mean by logic apps? I'll just recap. Where logic apps are used for building workflows. When we talk about workflows, what do we refer to? We're talking about processes, systems that move from one state to the other to make work efficient or seamless. And we also, you can have what they call loops, which I remember I mentioned. You have the yes or no option. If you go back to programming class, where we create loops, where if this statement is true, or if this is correct, or if this is spelled correctly, click yes, choose yes. If it is spelled wrongly, choose no. So that's just the idea. You just need to understand the idea of loops. Using emails, 365 events. So one thing about the logic apps is that it can be triggered. How do you get to trigger it? You can trigger using an email. You can trigger using 365 events. And one thing about these triggers, usually it works based on your subscription in Azure. So there's some subscriptions in Azure that you may not be able to create triggers and set them up. However, we'll do a bit of practicals later in a few minutes just to show you how to set up some of it. And we go on to the logic apps. The logic, sorry, what I just explained, what I was talking about the logic apps, yes. So one of the characteristics of the logic app is that it can be used as serverless enterprise integration. PaaS can be used under the serverless enterprise integration PaaS. It has 200 plus connectors, meaning that you can connect it to external, that's logic apps. You can connect it to external, you can integrate it with external platforms like Google, or even platforms like JotForms, Google Forms, and other things, other connectors. You can also, one thing about it's designed for business processes. That's the logic app. It's designed for business processes, workflows, data systems, and services. So example, I want to provide a service that says, okay, each time my staff, my employee, it's their birthday, I would want my Outlook or my email to send them a special email stating, or to store a certain file on their system to say happy birthday, or a card. Maybe I have a picture or something of them, and I say, okay, I want to create an app that will store their pictures, carry their pictures, and play a video, for example, play video on their birthdays. So that is one way you can design a process using workflows. You can design data systems and services. It's a no-code solution. That's one of the functions of this logic app. It's a no-code solution. It helps you. You barely do any coding for logic apps when you're creating using logic apps. One thing is that there's something called the Azure Logic App Designer, which we'll go on to later. This is where you do the designing. You just create the app, and you can create the functions, and you can add functionality to it, different functionality based on what you're trying to achieve. Then I'll move on to the event grid. The event grid is a tool. It enables you, it's part of the serverless computing in Azure that enables you to route messages across different services. when you route messages across different services. So what I mean is we have the blob, we have the Azure, we have the event hubs. For example, these are just examples though, where you can create an event routing service. So when we talk about this event routing service, for example, you want the app to create an event from the blob to storage to the database. An event grid can be used for that. It will send messages. It knows how to route the messages across the services to say, okay, this message is for point A or server A. This message is for virtual machine B. This message is for the container in A or in B. One of the things it does is that it helps you publish your subscribe model. It uses publish subscribe model. It is designed for event-based and even real-time applications that run on, for example, like Outlook, that people use in their offices can be considered. What other real-time application? Let me say, okay, no, Bolt, your Bolt or your Uber can be like a real-time. It could create an event grid when you are using this. So I would quickly move on to Kubernetes, because then we'll come back to the Azure practicals. So for Kubernetes, I'm sure you have heard about it, you have seen it, you have seen stories about it. Usually the short form is usually K8S, 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 K8S. The reason is because usually they count the 8 characters. See it, K8S, UBER, that's 4, 5, 6, 7, 8. 8 letters in between. So it's usually short formed as K8S. So there are places you may have seen it, you may have seen online, we talk about K8S, and you're wondering what is this tool about. It's a tool that allows you to manage, to automate, to scale and manage containerized applications. So when we talk about containerized applications, what are we simply trying to say? We're trying to say that these are applications that meet 3 standards or meet 3 functionalities, perform 3 functionalities. So imagine a containerization process can be described almost similar to what you call virtual machines. In this class, I'm sure you've heard a lot about virtual machines, VM. And so a container can almost be described as a virtual machine. However, there are differences. There are some differences they have. I will just quickly highlight some of the differences. Sorry, excuse me. Some of the differences when we talk about containerization in virtual machines and containers. Virtual machines and containers. Both of them have operating systems which they use, and they have resources which occupies their memory. But one of the differences is that virtual machines use what they call the hypervisor, but containers use runtime engines. They also host operating systems the same way a container can host it. So what this runtime engine does, sorry, excuse me, 1 minute. So one of the
what this runtime engine is, it manages and executes your function. It manages and executes your function. So when we talk about this runtime engine, it manages and executes your function. So for example, when I'm using a container and I want it to probably I created a container to with a data let me see, let's use this app like Google Google Airbnb. Okay, let me use Airbnb. I don't know how many of you have heard of Airbnb. Airbnb is a rental service for getting rooms, like a sort of hotel, but maybe at a cheaper rate, because you sometimes have to use people's houses. Some people rent their houses, rent their spaces, and some people are actually in the business of using that. So, but this one uses the virtual machine, uses the hypervisor, which uses the Hyper-V. It enables the computer to specify guest partitions that have separate address systems. So what I mean is that the separate address space allows you to load an operating system and applications. That's what the hypervisor does. But meanwhile, this one just manages and executes it. It's not bothering you too much with details. But for the hypervisor, you have to usually set up this on the Windows Hyper-V. But this usually works automated. Doesn't require much from you. However, you need to know how to configure and set up a container. And you can see, like I highlighted here, the functions are similar. But in defense of hypervisor, one does the runtime, uses the runtime engine to manage and execute. This other one does what they call isolation, platform integrity, audit. It has an audit capability, that's hypervisor, audit capability, and defense in depth, just like your virtual machine, as you have heard in your previous classes does. But the runtime engine manages and executes from the operating system and even the hosts OS. So I'll go back to our Kubernetes that we were talking about and containerization. So Kubernetes is known as a tool that helps you to manage, to automate, scale, and manage containerized applications. So we have just talked about containerized applications. We said they work like your virtual machines, but the difference is they have the runtime engine, which works differently from the virtual machine. Note that they work differently from the virtual machines, but yes, they have the principle, they have similar functionalities. If you talk about their characteristics, it's almost similar, but just slight differences. So the Kubernetes uses YAML to define the resources sent to the API server. It uses YAML as a form of language to define the resources sent to the AMI server. So some of the features we have in Kubernetes, the K8 master, we have the K8 cluster, we have the Kubernetes. K8 master, K8 cluster, Kubernetes. So these work, this is where I need your attention as much as possible, because I would like to explain this in details. Because when you understand the way this works, you understand Kubernetes. When you understand the way this works, you understand Kubernetes. It's very easy to understand when you understand the way this works. So the admin UI, the command line prompt, when you enter, or the admin portal on the Kubernetes, you have what you call the controller. You have what you call the controller manager under with your Kubernetes. We have what we call the scheduler. We have what we call the etcd. We have the API server. We have the port 1, port 2, port 1, port 2, usually. All this consists of what is called the work mode. I'll go back again. When we talk about the work node, this helps you to run containerized application workloads. So you can see this is work mode 1. The whole of this place here is what we refer to as the whole of this containing the container runtime, Kubernetes proxy is what we refer to as your work node. That is like the house for the containerized application workloads. That's what it does. It's like the house for containerized application workloads. So this is how it works. Then we have your control plane. Sorry, I didn't add that here. From the admin, usually the first step is that from the admin or the command line interface, the first thing you have is what they call the control plane. Control plane. I would like to, it's just I can't edit on this screen, but I'll edit this. We have the control plane. The control plane is the house that houses your controller manager, it houses your scheduler, it houses your etcd, as I have highlighted here. Your control plane, note this, please listen to this. Your control plane is the house that houses your control manager, your scheduler, and your etcd. So what happens here in each of these scenarios? First, your etcd is the one that retrieves information about your customer. It retrieves information about your customer. So when you are setting this up for an organization, how you can retrieve information, how you can retrieve data, how you can store. It is used to store and it is used to retrieve. That's what the etcd does. It's used to store and it is used to retrieve. Then we move on to the scheduler. The scheduler has what you call the scheduling of pods. It uses resources to make placement decisions. So how do I mean? So for example, it says, okay, this service, when it comes to messaging service, when it comes to your service for maybe deployment, or no, let me use another example, like the way you have your boats, you can have a scheduler in the app that schedules, okay, this location on the app, your driver is at so location. This is where these are the things this is the area he's located at. And it will pick that information, take it to the GPS system to track the location based on the phone data that it is getting on the phone of the driver in both. So the scheduler can perform such functions. It makes what they call placement decisions. Then I'll move on to so note that, so when you have this admin CLI, it goes to the controller with the API REST. The API REST is the one that takes it to the control plane, When it gets to the control plane, we have the etcd, we have the scheduler, we have the control manager. So when you get to the scheduler, it does what is required by the pods, the resources to make placement decision. Then it moves on to the controller manager. In the controller manager, it manages controllers, it manages the state of the customers, it manages rollback. When we talk about rollback, just as it manages when you're trying to deploy, make deployment or put the app, make it live for production. So these are some of the things that it manages. Under which we move on, it carries to the API server. All this work in hand and sent to the API server. And the API sent to them invariably. Then we have the API to send to them. I should have given an arrow to send it back like that. Okay. So the API server, what does this server do? It serves as a house from the control plane. Then the next is that we move on. Notice this here. You have the kubelet proxy, you have the kubelet, you have the container runtime. I'll just explain the kubelet first. The kubelet is what receives instructions from the control panel. Remember that I said the control panel is from here. So we have the kubelet down here. And note that it passes through the API server and then it comes down to the pod and then goes to the kubelet. From the kubelet, it goes up again to the container runtime. From the kubelet, it goes to the container runtime, to the pod, the API server, and to the control panel. The control plane, control plane, that is. What does the control plane consist of? Consists of your controller manager, your scheduler, and your etcd. That's what it contains. So then I move the container runtime, the kubelet container runtime. So when we talk about the kubelet, what are we saying? The kubelet is like the smallest deployable unit. Note this term again. The kubelet runs on every Kubernetes worker node. Sorry, it's the worker node. Every kubelet worker node. The kubelet runs on every kubelet. Sorry, the kubelet runs on every Kubernetes worker node. So this is a worker node. I told you what a worker node consists of, this whole thing. Note that this entire thing here is control panel. This, is control plane. Why am I even saying control panel? This is what we call the worker node. So you can see the relationship through the API server. See the relationship through the API server. So first of all, we have the kubelet. Kubelet is the smallest form. So we have the kubelet. The kubelet runs on every work node. Then we go on to the container runtime. Hope you know that this entire diagram here is what is referred to as the Kubernetes cluster. Kubernetes cluster. Let me explain what the Kubernetes cluster is. Is a set of machines with nodes to run containerized application. Where are the nodes? These are the nodes that run containerized application. But the entirety of everything, the control plane, the API server, the nodes, this is what consists of the nodes, this here. As you see my arrow moving, circle the pod 1 and pod 2. They consist of what is called a node. So we have this, we have the container runtime. what does this container runtime, what does it do? Container runtime. It pulls containers from the registry. Container runtime pulls containers from the registry. Images from the registry. See it here, container runtime. And see every of them has a container runtime. It pulls images. For example, I want to say, oh, like the example I gave of I'm the CEO of a company. I say, okay, I want to send videos to my employees any day of their birthday. I now try to configure this using containers. I now say, okay, let me set up first. I set up what is called a Kubernetes cluster, which consists of all of this. Then I put in all these things. So the container runtime, it's pulling containers from the registry. It's pulling containers from the registry. Pulling images from the registry. So that is what this does, container runtime. Pulls images from the registry. And one of the good things is that about Kubernetes is that it performs automated rollbacks, horizontal scaling, cloud portability, app portability. When we talk about app portability, cloud portability, it means that the ability to adapt, the ability to put in, how do I call it, to meander seamlessly without to connect, to join seamlessly without having issues with other applications. So one of the drawbacks of Kubernetes is that it's expensive. Sometimes the cost of creating the on-premises is a lot. Because Kubernetes has helped us to provide a uniform way to package applications. That's the summary of everything. Kubernetes has helped us to provide a uniform way to package applications. So sometimes you don't really need to sit down and be thinking of what framework will work, what libraries are suitable on this application I'm building. Kubernetes has done it for you. One of the things that Kubernetes is also good at is it can be used for Amazon EKS. It can be used for Google. There's what they call Google Kubernetes engine. Then there's the almighty Azure Kubernetes service. Azure Kubernetes service. These services allow Kubernetes without thinking. These Azure Kubernetes services, these services allow you to create Azure and add Azure into services that you are not bothered about the infrastructure. So one of the skills that is very key is how to set up, how to configure your control panel. That is how to configure your etcd, your scheduler, your controller manager. Then how to scale your cluster. So you can see this entire diagram I've shown you is a cluster, all from the admin down. It's a cluster. They are all clusters. They're all clustered. So we have what is required, configuring the control plane. What is required when you are using Kubernetes? you have to know how to configure this controller manager, the scheduler, and the etcd. Then providing the ongoing maintenance support. Providing ongoing maintenance support. So I'll quickly go back again. So I hope with this you have understood Kubernetes in a brief summary. It helps you to manage, to automate scaling and of containerized applications. Okay, we will go back to our practical. However, I just want to highlight something a bit. Serverless computing is a way of hosting your applications in the cloud. In other words, so we have the serverless computing is a way of hosting your applications in the cloud. In other words, cloud. I've said that before. So we will go back on to I forgot to explain what a pod is under Kubernetes. What is a pod? Because you will hear this term very often when you're talking about containerized application. Pods are the smallest deployable units. Pods are the smallest deployable units in Kubernetes. Containers exist in pods. Note this, containers exist in pods. What are pods? Pods are the smallest deployable units in Kubernetes. So the smallest deployable unit in Kubernetes is described as a pod. And note that when you are talking about containers, creating containers, they only exist in pods. So these are the things I just wanted to highlight for containers, Kubernetes, and serverless computing in Azure. However, we'll quickly move on to operating system. So remember when we started, we said cloud computing allows you to build applications using code, multiple servers, and allows external services to communicate. Kubernetes is also known as K8. So you can see Kubernetes K8 master, K8 cluster, kubelet. So what does a kubelet do? What does a pod do is the smallest deployable unit in Kubernetes. Able to convince you and not confuse you. Yeah. So okay, we'll move on to another part of the class, which is practical. So we come back here, and now we're looking at how. Let me do a simple, quick class. How we can create our logic app. Okay, simple put. So first and foremost, we'll come here, we'll create a resource group. We'll start with a resource. Okay, we come back to our home page. we will come here, resource group. You can see this here. You can create this subscription. You have to have a subscription that is working. So we have this MSPT, MSDN, which is working. We'll create a resource group name, cohort cohort 6. Cohort 6, we use West Africa, or we switch to Middle Belt, South Africa. Okay, let's use South Africa North. South Africa North. Then we'll click on here. We'll click on the name, resource MS, resource usage. There's one option. Okay. So here we have the MCT MSDN platforms, cohort 6, with our region set as South Africa North. So we create this resource group. Where's our resource group again? Mm. Okay, see our resource group here. So we go to our resource group. Then we move on. Yeah, so here you can see our resource group here. Cohort 6. So under this, we now go to create our close. We choose a service here. Let's say, let me go back to okay, see some of the IT Azure consulting and managed service, apps needs recovery, Desktop, capture. Let me use okay, let's use Fortinet. My office uses Fortinet. We can create it here. Okay, create. So I'll go back to so please hold on. Okay. I want to check for logic Azure designer. That's not good. Remember we talked about event subscription. We talked about um the three features, the three important areas such as of serverless computing, which is Azure Functions, Logic Apps, Events, Bridge. So we may not be able to do all the practicals for that here because of subscription, but let me do one, and which is let me do the one for let me do the one for Logic App. Let's start again. So let me go Logic App. Okay. So so you can see here we're logged in and we're on the Logic App. So what I want to do is to link it to an email, connecting it with a database like a storage like Blob. As you remember, I hope you remember something called Blob for storage. So what we're trying to do now, let me come up with something practical that you can relate with. So let's say we want to create a trigger because when we talk about the Logic apps, we're talking about workflows. And usually for workflows to work, you need a trigger. So now I'm saying, let us start with so now we're saying, okay, let's create an email. So for example, you are a HR manager and they said, okay, create a trigger that will send emails to the users and download a video, or it will store on your employees, it will store, let's put it like this, it will store data, it will store something that has to do with their birthday. It will store the file or the folder that the company has created for their birthday. So because I'm using birthdays because I know birthday is easily to relate. So what this does is that you can now come here on your Logic app. Simply we're saying add apps to display. So let's do this. Adding so usually based on your subscription level, it allows you to choose. So now you can see this here, we're creating a Logic app. We have to select a hosting option. Can you see these hosting plans determine the resource app allocation, scaling and pricing for your app? So you note that so when you're creating apps in when we talk about the serverless computing, this is one of them. So here you're not bothered with the server, you're not bothered with too many things, but you're creating an app. You're not bothered with the infrastructure of the app, but you're creating an app. So here we talk about the resource allocation, scaling, and pricing for your app. Let's choose this workflow service plan. Yeah. Okay. So we have created it. Let's go to our resource group. We choose cohort 6. So we now create an instance detail Logic app name. What name do we want? Okay, let's use cohort 6. Cohort 6. Cohort 6. Yes. Cohort 6. You see that it has ticked it as good. You can see cohort 6.azurewebsites.net. Okay. This is about to get interesting here. So we now choose which country. We had chosen South Africa North before. Now this South Africa North, these are the options. Windows plan, a Windows plan that is we can get. So you see the workflow standard. See the memory size, 3.5 gig memory. So also note that some of these plans that you use is based on how frequent the data will be accessed. How is it every minute? Is it every second? Is it every week? Once a week with this data? Well, you know, this is something that you know you want it to work every day. So in our case, we say, okay, enable your app service plan. Then we go to next, storage. We have chosen Azure storage. The storage account cohort 6. Okay, we have to have a storage account existing. Okay, let me use the other one. Let's see this one. Cohort 6360. Okay. Then we now say you can configure diagnostic settings later from the storage account resources. Choose this if you want full control over log destinations, retention policies, and which logs and metrics are configured. Yes, we want full control. But you can also choose this option of configuring basic diagnostic settings, which uses Azure Log Analytics with storage write logs, transaction metrics for the blog. You can modify your settings from the storage accounts resource. So our workspace is already, we should leave it as the default. Then we go on to next. We'll enable public access. We'll enable virtual network integration, your VNet. So now we don't have any VNet existing. We have to create a VNet. Okay, let's do it for now because the VNet has been taught in the other class. So we'll move on to next, monitoring. And then we will review and create. So we now enable application insights. This enables you to have, so your application, you can get real-time data. Oh, this application is performing well. Oh, so person has clicked on this application. Oh, number of views, number of people that have used the application in a certain day with dates and all this kind of data. That's what you can get with this application insights. So this now we can now click on. So this I usually leave it as so we can say, so tags enable you to categorize your resources and view consolidated billing by applying the same tag to multiple resources. So for example, if I want to do it like now, I say, okay, based on departments, send birthday, this is based on departments, maybe a value of 1, resource selected. Next time I say send on MS resource usage, Cloud Shell. So it will share these resources, all resources. So I can just click on the logic app. I can remove some functions that I don't want. That's the beauty of this. So you see where the tag you can remove some things you don't want. So for example, maybe I want, okay, I'm sending to another group. Maybe I'd say, okay, these people, I don't want them to have access to certain information. All they should just have access to is this, is the logic app without any. So you can see that the name, the value, the logic app, but maybe all departments, and I'll say every department, I want them to have access to this app. Now we've created. So you can see we have created a work service plan. So now we'll go back to this. You can download a template that would go back into your to your email. So after we have done this, you can have automated deploying resources with resource manager. So you don't have to use what we just did now. Now I just use the blank this thing, but you can use a template to create your logic app. All you need to do is just edit some of it, and you get. So let's go back to our let me see, where's the view? Am I not seeing this thing again? Okay, I know, because I didn't create. So let me put this here. So we have the logic apps custom connectors. We have the logic app templates. Let me show you what the templates are. Okay, let's do this. Create. Let's go to the template. Okay, so we say we use the subscription, we load our cohort 6 resource group. We move on to name, resource details, cohort 6. West region, South Africa. Review and create. So see here, we have created a logic apps template. So what this does is that you can connect it, you can automate it with another process. And so you can see it here. So right now we're trying to, you can automate it with another process, which is automation. So you now say tasks. Add a task. You don't have any automation template here. Okay. So you can see that this is send monthly costs for resource. No, we're looking for another template that has something to do with birthdays. Okay, there's no template here that has birthdays. Let me see, we have to create one. Okay, let me just use this. It will send monthly costs for resources. So this, let's just use this one. Where does this send this? To your Outlook 365. So we're connecting it to Outlook to say that anytime you are using, so now note, we've changed it. Anytime you are using the Logic app, we're now sending from our Logic app, we're creating it to enter into our Outlook to send billing or costs that has been spent on this Azure subscription. I wanted us to create something for HR, like a HR resource that tells you, okay, this person's birthday, send them an email save the file on their system, on their desktop, and save it in a storage or in the database that is also is birthday. But there are some limited features here with the because of the subscription here. I can see the subscription is about $100 plus, not so much, but it's quite okay for us to. Okay, but let's just do this. Okay, authorize Outlook. So what we're doing now is that we're giving Outlook access to our Logic app. We're giving Logic app access to Outlook. Let me use another account. Let's see if I can use my. Okay, I think this account can be used. My Outlook account. If I hope I remember the password of this. Okay. I know. It's so much to give us an Outlook account and send. Okay. I think this account, I have the password now. I usually sent it as. Okay, let me try this. Wow. Something is. Let's see. Okay. I need to. Wow. This is serious. And I can't use the same profile on my for this email. Okay, let me try. Which email can I use now? Okay, can somebody volunteer their email? Let me try this again. But I've logged into this thing before. I used okay, let me try this the class. But you might need to show us. Sorry, are you here? So what we've just done now is that we have connected our Outlook to our Logic app. So I've given Logic app access to Outlook to send a mail to our Outlook to say so resource price. This is what has happened at so date. This is the subscription level. This is the for this app at this date on this day. Then we can also give access to the resource manager. what the resource manager will do is to manage our resources too. So this is it. It will be like a monitor. But I'll not log into that one because it also has. So task name. Let's give it a name. Cohort 6. Cohort 6. Hey, why do I like using cohorts? Cohort 6 projects. No. Let's target. Okay, cohort 6. The email should be sent to somebody should send me their mail. I'll add them to this list here. So email should be sent to somebody should give me a sample mail to use in the chat box. There are people in this class. Okay. Okay. So nobody. Okay, I've seen an email. Okay. Let's add this here. No, we added. Okay, let's look for an Outlook email too, so we can use that to check. Okay, authentication failed because we added another this thing. This is the authentication. Okay, let me just log into this Azure Resource Manager. Okay, yes, I remember because we had chosen Azure Resource earlier on in our options. So this is why sometimes you have to be careful. So sorry. Okay. So now next is configure. Okay. So she'll go to her Outlook. She should get a mail saying that this is the resource and this is the cost of the application that was created. So so the preview here, let me see, where would I what's that? Okay, so we would so you can see spending rates and forecast here. So you're supposed to send a mail like this, something similar to this, to her mailbox. So what we just accomplished now is a logic, like a logic app, which is like workflow, something that you just create some process to achieve another project. So we have the Azure Azure function. And the thing is, I'll look at there's so many things you can do with the Azure function. As I had described earlier, it's like you see Selenium on Azure functions. What does this do? This enables you to create virtual machines to deploy Selenium scripts within minutes. It automates your Chrome within Azure. That's your Google within Azure. And it enables you to use Python. See here, use your ready to use Python environment. So you can see I'm saying Selenium on Azure functions. So what I'm trying to do here now, I'm trying to use this particular tool with Python to use some coding, do some coding and create an app. This requires a bit of more, but it is also very, okay, let me just do something small. There, our resource group again, code 6, our virtual machining, because the reason why I'm not doing this now is because I didn't create a virtual machine on this account. Usually when we use these subscriptions, we clean them off because of the cost. If you leave them to run, you might come back tomorrow and find out that your wallet is empty. So when we practice and just use them for practice and for the practical session, we move through these sessions. And so we have the virtual machine name, we have the region, we have the availability zones, which we have talked about in previous classes. We have the availability zone 1, in this case, security type, image. I hope you know why it's important that your image is properly chosen, because you don't want to you don't want to set up an image that cannot be used, that's too bulky for the virtual machine. When we talk about images, talk about file size, and we talk about image size, because sometimes we have some images that we're trying to use on our virtual machines that are very heavy. And for that reason, it slows down the virtual machine. I remember one time we created, I think it was last year, we created one virtual machine. Later we discovered that a lot of the images we had in the registry were very heavy. So we couldn't, it was making the virtual machine slow. However, there are methods you can use to compress, but it's also good to consider the option of whatever it is you're using. Okay, so I will go back to I'll go back to anybody, any questions so far? Okay, what's the difference between a logic app and a web app? So the difference is that a web app can be run. A logic app was created by Azure, Microsoft Azure. But the what's it called? The web app is not subject to Azure. It's not how do I call it? It's not customized. It's not made for Azure. Okay, I'm just seeing an email, Sherilyn. Okay, it's not customized for. Let me send a material now to give that this thing clearly. So usually what we have is that the two of them, the good thing about the two of them can be cloud-based services, but they are for different purposes. So a web app requires hosting of web application, but the logic app just does workflows, processes, systems. There's what they call the visual design, logic app visual designer. It helps you to integrate connectors. So you're not doing so much coding. So one of the first differences is that the one is automated and it helps you to orchestrate workflows. You can trigger workflows, you can trigger processes. The other one, on the other hand, does not. It can do that, but it's not giving you that customizable feature like that. This is more of your creativity. See it as, let me just explain the logic behind. One is created by Azure. One is a web app, can be used by anybody, created by anybody. But the logic app, they can do the same functions, which is they can automate processes. I can create a web app today to say, okay, automate this process to this place, do this to do this. The same thing that a logic app can do. But the difference is that one has a pre-built connector to integrate various services without me coding. But the other one requires, I can develop this web content, develop several functionalities, but I have to do it through code. So what happens is that the visual designer is what the logic app uses to create workflows, because it has already existing, that's for the logic app, it has existing connectors. But for the web app, I'm talking about something that has to just do with creation. You can, so because like now when you create a web app, you are either talking, you can create with Python, you can create with JavaScript. I usually like to use JavaScript to create web apps. And you can use, then you're talking about your framework. What kind of framework are you putting in place, like Ruby, other frameworks you can use that can merge with the language, programming language you're considering. But when you're talking of logic app, you're not bothered about that. All you're bothered about is, you're not bothered about, oh, can this merge? Because logic app in itself can merge with a lot of apps, programming languages, can merge with a lot of programming languages. So let me put it like this to you. This is like the shortcut. Logic app is like the shortcut. Web app is like the longer route. However, you can create a web app that has the connector inside, that has a connector that ties to a logic app. That's the thing. Good question. I mean, that's, yeah. So the two of them, one One is for host. It is usually more of hosting web applications. Then the other one is for automation, workflows. So that's what, let me just put it that that's the greatest difference. One has to do with workflows, automation. The other has to deal with hosting of web apps and web applications. And one has low code, the other is code based. So so anything code based means that the ability to scale with the web app is higher. You can scale it, you can do a whole lot, even with the logic app. So what I would advise is that the logic app is better for complex, more advanced, complex solutions, enterprise solutions, let me put it that way, enterprise solutions that have a huge workflow. For example, if you're a bank, you don't want to sit down and be creating, how people send emails to manager for approval all across your branches across Nigeria on all your virtual machines. You can simply implement with Logic app and it would create that workflow for you all across all your branches on all the virtual machines that are connected or the containers that you have, because that's why there's something called containerization, where you can put your machines in containers so that in clusters, so that you can now have whatever you put on A, you don't have to go back to C, B, D, F, G, H and go and be implementing it on each of them. Whatever resource you use in A is also applicable to B, C, D, F, like that. So there's not much you need to change. We've come to the end of this class. I hope you have understood much. The truth is, some of this is you may not understand it immediately, but frequent use would enable you to understand how to use it. However, it's also important that you understand the principles behind it, the principles behind logic apps, the principle behind web apps. Yes, they're similar in a way, but they have differences. One is easily is for automation, integration of workflows. The other is for hosting web applications. Okay, filling the attendance register for today's class. Okay, thank you. Then I will just let me go back to okay. Can you see my screen? Pink lady. So with this, I hope you can decide to pick a career in serverless computing as a way of hosting your applications on the cloud. The thing is that these three here, Azure functions, like I mentioned, we have the event grid. However, even though I didn't go delve into the event grid, let me still go back to this event grid. Take on. So this has a bit of okay. So you can see what the event grid it looks like. We have the publish and subscribe messages between MQTT clients. We have the system topics, automate tasks based on Azure service events, custom events, Custom events means that you are creating, you want messages to come. So build message-driven applications with flexible consumption patterns and protocols. Publish and subscribe your application events. So what this does is like where you say you track what happens on your app, what you do. You can do, see this option here, topics in Kubernetes. You can publish and subscribe your application events on Kubernetes, create, for example. And you now make sure that Kubernetes, you create your event grid to send messages to your Kubernetes. And remember that I talked about the Kubernetes. Kubernetes is an open source. It's an open source tool that contains the orchestration tool. It allows you to manage Kubernetes service. What does this Kubernetes do? It helps you, remember this part, it helps you to automate deployments. It helps you to scale and management, and helps you to manage containerized application. What are containerized applications? Containerized applications are applications that are, let me say, simply put, in a container that carry 3 characteristics. So I don't know if I highlighted this part, but let me go over it again. Some of the characteristics of a container is that it must describe, you must have a description for the container. You must create the image. Let me do this. Container instances. Okay. So we create a container instance now. Let me do this. Let me just do this practical. Create a container. We have a resource group already existing. We create a container name. Port 6, South Africa North. Availability zones 1. We only want it to be available in 1. Quick start image, run with, no, this is okay. Image is Microsoft.com, Azure Docs, hello world. Ports, TCP, yes. One. Then enable container instance. Yes. Restart policy on failure. Well, this is a long. So now we have created a container instance. And so when we create these containers, you can now put them in. When we create these containers, you can now put them in the management of containerized applications. So what is the thing that does the management? Validation pass. What is the tool that does the management of containerized applications? What's the tool that does the management of containerized? That's your KOS master, your K8S master. That is the tool that does management for these container instances. And why do you use containers? Remember that we have what we call runtime engines. Runtime engines. This one stores, executes, and follows instructions. So it's almost like you created like a lot of AI. This thing can work with this. A lot of AI tools today work with the runtime engines. When we talk of Azure AI, there's a lot of containerization in Azure AI because you use the runtime engine. How the runtime engine works is that it makes sure it goes to verify certain things based on certain data patterns and structures and all that. So it's adaptable. Then another thing of containerization is that you have to create an image. And how do you get an image? You build an image from the registry using through the API. Then another thing about containers is that it can be shared on all platforms running within the same cluster. Within the same cluster. So the good thing about containers is that you are not sitting down to configure one thing. For example, I'm not sitting down to implement Azure or maybe implement Azure Resource Manager on all my devices. Once I put in the container instance, whatever I apply, whatever service I want to be on all the platforms, to go on all the platforms. I don't need to start assigning, oh, this one, I don't want this one to go for this. I don't want this one to go for this. I can just set up a configuration at once and to apply all the services to all my resources. Using, for example, if I say, okay, only use on all my containers, only make sure you use 60% of the space of my storage space. Don't use more than 60% to store images. So you can write such kinds of codes. Or sorry, you can create such kinds of instances for your containers. So, okay, we're done with the class. And remember that pods are the smallest deployable units in Kubernetes. I hope to see you in more classes. And note that Kubernetes was traced back to Borg, created by Google. KA8 was created, KA8S was can be traced back to the time of Google when they used to create and store things in containers. So you just, okay, so, okay, this is my file, my images are stored here, my registry is stored here, my operating system is stored here, my regions, my resource groups are stored here, and stuff like that, my metadata. And you have specifications, you don't have replicas, you have API, or my API versions are stored here. So these are some of the things you use. These are some of the reasons why people use K8S, because of its containerization, the ability to manage containers, the ability to control. It also has what they call Kubernetes proxy. What does this Kubernetes proxy do? It helps you to route traffic to the correct pods. You are able to do load balancing and all the likes to the correct pods using Kubernetes practice. Then your container runtime. This one helps you to pull containers, images from your registry. You are able to check and say, oh, I like this image. Remember that we talked about the scheduler. The scheduler is able to tell you, okay, this is the image for this. This is the image for this server. This is the image for this location. This is the image for this place. Send it to this. Send it to that direction. Send it to, it's like saying a letter. Oh, I got a letter from Lagos and I'm in Abuja post office. No, this letter is for Lagos office. Send it to Lagos office, something like that. So these are some of the things that we need to really understand. And I hope you have understood the concepts, basically. Is the registry the same as Docker to get your images? Well, no, is not. Though they are related, but one is a platform for you managing containers, while registry is a service where you can store more of storage. So the Docker enables you to manage, yes. So the Docker enables you to manage your containers. So note that it helps you to manage containers. Then the other one is like a service that stores. It enables you to have your images where you can pull out from.